In this Grasshopper tutorial, I want to show you how you can convert a base surface, which is this surface, into an inflated one, which we can control. And this is going to be the final mesh. So as you can see here, we can fix a series of UV curves on the nerve surface. One of the inputs we're going to talk about, we're going to open the cluster. We're going to talk about the example file and how it works. Let's take a look at the inputs and outputs of this cluster. So first of all, there is a flip UV, which is going to change the UV direction of the fixed and free edges. So I'm going to put this to false. So I have in this U direction. The U repeat is how many times you want to repeat the pattern. So for example, as you can see here, we have a fixed free pattern. So it's a 3. That means that 3 of these isocurve edges are going to be fixed. Then it's going to be 6 of those which are going to be free. And again, 3 of them are going to be fixed at the end. So that is one pattern. If you put this to 2, obviously it's going to, let's put it to 3, for example. So again, we have this pattern repeating 3 times. So as you can see here, it's going to repeat, and at the end we're going to fix it because we want to fix edges and not inflate at the end of the parts. Anyway, the next thing is the resolution of the V, which is going to be the resolution in the second direction. And as you can see here, it's in this direction. There is also the fixed free number of, for example, if I put it to 1, as you can see here, 1 edge is going to be fixed and the others are going to be free. Another thing is the inflation, the amount of inflation you want to give to the free edges. And also you can flip that direction if you want to put it inwards or outwards. There is also an axial strength, which if you put to 0, it's going to be somehow like a tensile web. I'm going to decrease that to 4 and inflate it. As you can see here, it's going to give you more realistic puffing meshes output here. And you can get that something like this. This dash pattern is just for visualization, so it's not really that important. You can get that dash from here. The goals is going to be used for the kangaroo solver, and the pattern is also useful if you want to know how much the pattern is repeating. After that, we can use the kangaroo plugin. Here we can use, for example, the bouncy solver. Give all of the goals to the goal object, put a reset button to reset the simulation, and run a true and false for running the simulation, obviously. Then because the meshes is somewhere in the outputs, I've used the set tree clean tree to clean the tree. And as you can see here, we have the mesh as the first output. So we can use the set list item to pick it up, and that is going to be the base mesh. The resulting mesh. You can also use the VVirbid plugin. For example, I can use the VVirbid plugin and use the Catmark Clock subdivision and maybe just put this to 3 times smoothing. And also use the corner fixed as an output. So that is also a smoother mesh if you want to. As you can see here, if I go to the rendered mode, obviously, you can see that here. So, for example, if I want to see that better, I can use a custom preview and put that to Control M, turn that off. And now we can change that to like 2 times and increase the inflation. Increasing the axial strength will also give you somehow with a more structure-based puffing. So if I increase this, especially if you increase the strength, somehow it's going to be like this. Okay. If I change the direction, you can see that happening here too. But anyway, that is the main direction we want to work with. And finally get the results. I've also made another cluster, number 2, which is for a simple vertical surface here. As you can see here, the base surface is a flat surface. The direction, you can change it, but the main direction is the U direction we want to work with. So how many times you want to repeat it? Okay. And we run that. The resolution of the divisions, obviously more resolution will give you better results. And how much you want to fix. For example, if I put it to 1, only one edge is going to be fixed and then it's going to be inflated. And increasing this number is going to give you more details around each part, and increasing that is going to give you 2 edges fixed, 3 edges fixed, for example. Increasing this axial strength, inflation direction, it can go inwards if you want to. So for example, if I bake the mesh, you can see that it's going to go inwards. And that's it. That's how you can convert any NURB surface into a series of UV divisions. Let's take a look at the cluster and how it works so we can understand the logic behind it.